Good morning. I'm Dolphy Gilpin, coming to you from the Hyatt Regency Capitol Hill. And previously, I've just calculated I1 and I2 from this circuitry, and I've drawn a smaller circuitry here. We've also calculated powers associated with I1 and I2. And we've gone to I3, and this is to determine the power, the current first for I3, and then we're going to calculate this Vx here, V sub x, and the power associated with V sub x. So all right, so here we have the circuitry. And the elements and the value of the elements are shown, and we go straight to determine I3. So we say I3 is equal to 10 minus J2, which is the R11 here in this first mesh, which would be 6 plus 4 plus J2, which is a minus J2, so it's 10 minus J2. And for 1, 2, we have 0, and for 1, 3, we have 10. For I2, 1, we have 0. For 2, 2, we have 6 minus J6, and 5 minus J3. And so on. We have put in the elements by inspection here, and over there. This is our only little change we've made from delta to del in previous sessions in New Jersey and New York and California. We have used delta, but here we use del because we're going to associate del with the divergence theory and the Jacobian, and whereas delta is usually associated with a small increment. And notice, interestingly, let me get my little marker here. Notice, interestingly, that del is just the inverse or upside down of delta. So we write delta as so, and del as so. And notice also that if we superimpose del upon delta, we are like the Star of David. Star of David. Right. Or something looking like the Star of David. So I could also say the Star of David as for numerator. This is just algebra. Nevertheless, here we have it now that I3 is equal to 4.22.3 at the angle 82.66. That is when we do the calculation for the determinant here over del. And it's over now 6.27.7 at an angle 33.87. And if we do that now, we get 0.67, 4.22 over 6.27.7 is equal to 0.67. And we know that if we estimate this to be 4 and this to be 6, this is almost 2/3. So we do the estimation of this and say we're supposed to get something in the region of 2/3. We get 0.67 at an angle of 1.88.33. And this is amps. So we find Vx by saying no, Vx is equal to 2 plus J4 here now. 2, and the J4 is from the inductance, times I3. I3 is this current going around in the anticlockwise direction, in which we have determined from previous session. And I3, and we determine it here as this over del, or this over the Star of David if we superimpose del upon delta. And Vx is equal to that, which is equal to 2.J4 times 0.67 times 188.3. So that's equal to 4.472 at an angle of 63.43. And notice when we multiply angles, we add them. So if we add the angles, we get, we'll multiply angles, 0.67, 1.18, 6.43. And when we divide angles, we subtract them. So we get 3.181.76 volts. So that is the value for Vx. And so we could also find Vx, the power going through Vx element, and that will be equal to Vi. Vx times I. I have no space for that. We leave you to do that calculation. The power going through this element, or the component of the resistance and the inductance, would be I times V. And we have just calculated V to be 3.18.76. So that the power would be 3.18.1 times I. And I we have found to be 0.67 at 188.33. Okay then, so that concludes our determining I1, I2, and I3, and our Vx, and the power S1, S2, and S3 associated with them, the complex power. So as promised, I'll probably move over into some PDM economics configuration here in Washington, D.C. As here in Washington, D.C. is the capital of our economy, and we're going through problems in economics here, and we're going to give them the economic configuration and see if the economists, the expert economists, can bring about some solution to our economy. That is, if they adopt the PDM and its amazing applications.